Hi, this is a basic tutorial for SCIA Engineer. We will calculate a very small steel frame. From the input of geometry and loads, through the calculation, we will look at the results, run the steel check, and prepare a small engineering report for the output. My name is Ivan Beleš, and I am support engineer for SCIA Engineer and Idea Statica. We are in SCIA Engineer, and the first step is to create a new project. We have to decide the material. This is the default material. You can use different materials for each cross-section or each slab, for example. And the structure type. Usually I use general XYZ because this is a model type where you can use all elements, beams, columns, and also slabs and walls and so on, and shells. But for this structure it's enough if we use frame, then we don't have so much icons available. There is also functionality. We will not change it. If you need some nonlinear calculation, earthquake calculation and so on, you have to change it here. I will close this, and of course you have to select the national code. This is predefined for Eurocode, is according of the installation, and then you can select your national annex. In SCIA Engineer, I will do small changes in the user interface. First, I move this property window from right to left. You see, if I move it, then you see this pink small column on the left side, so small bar. That means that the property window will be glued or fixed on the left side, but with variable height. If I move it a little bit further, then you see a green strip. That means it will be glued on the left side over the full height. We have this input table. We will not use it in our tutorial. And then we have input panel. I move the input panel to the bottom of my screen. And you see again this red strip, then a blue one. That means it's on the full width of our window. And the green one is going through the full screen. So I use this blue one, and then you can adjust the height. So I change this basic modeling to all text, and we will start with structure. Therefore, I change the workstation to structure. We have some icon bars on the left and right side. On the right side is everything about view, the direction, what is displayed in your structure. On the left side is the workstation area where you can change what you want to do. For example, if you are working with the results, then you can change it to results, and with Alt you can change this orthogonal direction. So for example, I want to have vertical the concrete, then you can change it, or report or standard structure, and you can change the direction. And here with this hamburger menu you can change the content, what is displayed in this workstation section. Then you have menu where almost all commands are displayed, but not commands. They create something. If you want to create a beam or a support or something else, then it's here in this input panel. And then we have the input line. In this line you can write command. This is a command line, and you don't need to know the exact command. For example, you write view, and then you get all commands where the word view is a part of them. So we can delete. First, we start with a 3D line grid. I don't know if you will use it in each project, but in these standard projects like steel frames, it's commonly used. So I know the dimensions because I use this project over years. So 1.7, 1.8 meters, and the height 1.3 and 1.4 meters. we can change the display representation of this grid. This is in this drawing setup, so I can put off these grid labels and the labels what you don't need, and you can change a little bit of them. So manipulation of the model on the screen. If you push the wheel, you have pan. If you rotate the wheel, you have zoom, and rotation of the model is control and right mouse button. Not the middle button, right mouse button, so then you can rotate it. But you can also use this Navicube. So with OK, this is the name of the grid, I can close it, and this will be put on the screen. You see it jumps over the screen, so I cannot place it correctly. This is because of the snap points. There are here. So we have to change a little bit. So I will put off the dot grid. We will need the line grid because later, after I will draw the structure, I will use the I need these snap points from the line grid and also endpoints and centers. So you can adapt it. I will put off the tracking weights. So I want to put it in the 0 point with blank, with space button on the keyboard. You go to the input line and you can write 0 or 0, 0, 0, it doesn't matter. So 0 is enough. And for the end of the command, push the escape button. Okay, now we can move it a little bit. You see these small dots, we will not need it. I can put this dot grid off, then we have more clean screen. So, and I can start with the structure. So I go to member, and before I start it, I can say it. You see we are in the grid mode. So you can activate or deactivate this grid mode. This grid mode is off because I have pushed this drawing of member, then program is intelligent and turn the grid mode off. But usually if you are in the grid mode, you can change something on the grid. You can click on it, you can edit the geometry and the name and whatever you want. So, but usually turn off this grid mode, then you can draw the structure. You cannot select something if you are in grid mode. You can draw, but you cannot select the structure. So we start with standard member. Members and everything in SCIA Engineer has names. So you don't need to change it in this small structure, but in bigger structures it's good if you change it. If you use your own names, for example, W for walls and S for slabs and C for columns, whatever you want. We will change the cross section. I know all these cross sections. This model I got from a customer a lot of years ago during one training. So HEA 180, this is our standard cross section in this project. I can close it, close and close, and then I simply start to draw. If you don't have these points on the line grid, then go to the snap points and activate the line grid. So I start from here to here and draw our 4 columns. The first and last point of this line define the direction of the x-axis. So our columns are going from bottom to top. And then I will create also this frame from front to the rear frame. Okay, escape to close the command, escape again. If you want to change this behavior of the end of the command, go to this I, then to global UI settings, and then you can define that end of the function is the right mouse button. So like in AutoCAD, and you can change the rendering, for example. It's not bad if you use this full, then it's a little bit quicker. This is anti-aliasing. Hardware multisampling gives you the most smooth lines, and then you have another things. Every time you go in the settings, you can save these settings for future new project. And this is here. load and save settings, or you can load the default settings if you make some mistake. Okay, we can draw next beams. So I start again, 1D member, change the cross-section, go to these 3 points, then I am in the cross-section library. In the cross-section library, I have only one cross-section which is used. It's locked. I cannot delete it because it's used in the structure, but I can delete this one. So, or you can change it and create a new one. And this is one angle. You see it's predefined. Yesterday I have recorded the German video. So close it, close. In the properties, you have a lot of properties we will not use in this tutorial. For example, we will use the layers. So we have only one layer. Layers are like in your CAD software. You can split your structure on layers, then display them and hide them and everything else. So now we can draw the member. You see this is the midpoint. This is the point of the line grid. So from left to right and from left to right, and right mouse button. Aha, if you click on right mouse button and the end of function is not activated, then you can say confirm action, or you use escape. It's better. So now they are selected. Each time you input something and you finish the input, then these inputted parts are selected. As in, you can delete it, you can change the properties of these both members. There are 2 members selected at the moment. And you can do another things. You can copy it. If you don't want to use this copy function from here, then you can look here, modify, copy. If you don't know where is it, then simply write here, copy, copy, and then you can click on this show me, and then you see where is it in the menu. If it is in this main menu, not if it is in this input box, then you will not see it. So I go from here, copy from this point to this one, escape to close the command. So this is not very nice drawing on the structure. You can display it also on another ways. You can activate volumes, you can activate shading or transparency if you want. You can change colors, it's also here. And view setting for all entities. But I use not this command, it's too long. Right mouse button, and then you can go to view settings for all entities. If you prefer to use shortcuts, then for each command, if you go with the mouse on the right side, you see a small green bar. You can click on it and simply push the buttons on your keyboard and push enter. Stay with the mouse on your command and push enter, then it's saved. So, and now if I push Ctrl E, I am in the command. So that's same like right mouse button and go to view setting for all entities. Usually you will see only these icons. If you need the text, you can activate the text. And for example, I can change the colors from cross sections. So, and you see the beams with the color of cross section. Where are the cross sections? They are in libraries. You can go to the library, cross section, and each cross section, if you go to edit or if you look on it, has some color. You can change the color, you can change material, whatever you want. Okay, continue with the input of the structure. Next cross section is a round bar, this one with diameter of 20 millimeters. Which color? Gray color. I change it, for example, to some red one. Okay. I deactivate this FEM analysis. This is for thick walled sections, but we need don't need FEM analysis for this one. So okay, and draw it. I don't know if I'm on the right button. So you see, then I have. This is not very good if you have so close these snap points. So we can deactivate the midpoints if we don't need it, and then it's cleaner. If you don't want to make mistakes, deactivate the track points. This is this tracking guides. Deactivate this. There is F7, so you can activate F7 or deactivate it. Use it on the start only if you need it. And if you want to be sure, you click only on existing points. You can activate this magnet, and then you cannot use some points outside of the structure. You can only click on the points. So I go there, put them off. So I draw the beams here. Escape, it's finished. I don't want to have bending moments on these bars because they cannot satisfy the steel check if they have self-weight. So they can take only axial force. This you can change directly in the FEM type of your member. So in the property window or panel, you have two views. This is a smaller and bigger view, and if you see everything, we can change the FEM type to axial force on. You can activate it directly during the input of the beams, but then SCIA Engineer remember this setting, and if you draw the next beam, it's activated. So I don't prefer it during the trainings or these tutorials for beginners. It's better if you do it later, but it's your decision. You see this ugly big circles, so they are really too big. This is a very small structure. They are designed for bigger structures. You can change the size for almost everything which is there, and this is in these scale settings. So first, I can scale the additional data, but then I scale everything, also the supports and loads. I don't want to it. I go to scale settings, and of course I know it because I do it for almost 30 years. So this is this line symbol 0.1. Close, and you see this is more nice. If you want to deactivate them, then again, right mouse button, view settings for all entities, and they are here this FEM type. So you can deactivate it, go to apply, and you see they are off and on. Okay. Now we need one beam here. Here, this beam is 2 meters over the frame, 2 meters, and is a one IPE 200. Then we will have small columns with each HEA 180 rotated in this way. We will also need to rotate these columns, and then we will have small this Phi20 bars as a tension beam. So this is what we want to input now. So first I will input the bar. I will deactivate this shading and also this volume, and we can start again with 1D member. It's very simple. Change the cross section. I use this IPE, where is it? IPE 200. So if you don't want to see all cross sections, there are filters according the nationality. So you can activate, for example, European sections. This yellow color on white background is not very good. Change it to green. Okay. Save it. So, and I want to start 2 meters from this point. 2 meters. So therefore I need snap point for the middle point. So this is this midpoint, and I need also tracking. This is F7. So you can midpoints, and I activate F7. It's tracking. So I start with this point. This will be my reference point. Push the shift button on your keyboard. Move to this node. Don't click. Only move to this node. Release the shift button and move the mouse to the direction where you want to draw it. Usually it's only 0 and 90 degree defined, but you can change it in the settings. So I go to the left side and I want to write 2 meters. So to go to the command line, I push the blank, then I am in command line, write 2, and enter. So now it's defined. And I go also from here to the right side. So shift, move to the node, release shift, move in the direction blank 2 meter, enter, and escape to finish the command. Escape. So it's still selected, again escape, it's closed. So this is one way. You can also write coordinates, you can use tables, but this is a good way for drawing of the structure. Use this tracking, use orthogonal, for example, then you don't need to write so much coordinates. Now we need 2 1 meter high columns. So I use this each AE 180. 1 meter is the height of the column. Put them here. This is the midpoint. If this is not the midpoint, you can activate the snap on the cross points. So here, and so you see it's not snapped directly. You have to stay with your mouse for the half second on the point, or at the beginning you can put F7, this tracking off, then it's a little bit quicker, and escape. So I use the tracking for the trainings only if I need it, and then after them I put them off. Later you will use it standard. So, and now again some 1D members, and this will be with this circle cross section from here to this point, from this one to here, and from this one to here. Escape, escape. Okay, the structure is ready. We have to change a lot of the structure, a little bit the model. So, but you see the cross section, it's not very good color, so therefore I go to this IPE and change the cross section what we don't have. For example, this orange one we don't have. Okay, close. So we have different colors for the cross sections. The next step is to input supports. There are in this input panel, there are supports in nodes, but there are also hinge supports. They are prepared for us. So selection, I want to select them. So you can click on these points. You can also click and move your mouse with the pushed left mouse button. Then you have a selection window. This is standard in all CAD softwares. If you go from left to right, then everything is selected which is completely in this rectangle. If you go from right to left, you see a dashed line. That means everything will be selected which is completely inside and which cross this line. So for this input it's not so visible, but if we want to select, for example, with this window, then only a part of the members will be selected, only members which are completely in this window. If I do the same from right to left, then more members will be selected. There are also another possibilities. This is the basic which you will use 90% of your time. And we have to input some model data. I need hinges, so I deactivate this shading. Also this shading, if you want to have it on your command, for example, I use shading for S and transparency for T, and volumes I have V. So I can write volumes and toggle volumes, I write V. If you need this command also in your process, how is it? Workstation section, sorry, the names. You can activate, for example, my workstation with Alt. With Alt, you can click on it, and then you can use this command and move it here. Then we have volumes, and then, for example, transparent will be T, and you can again move it, and then it's duplicate, but it's only to show you how you can create your own workstation area. If we want to delete something, simply take it and move to this basket, and then it's gone. So I go back to the structure with Alt and click on the structure. Alt, therefore, because the main direction is here, this is with standard click, and with Alt click you can change the orthogonal direction of the workstation. Where we are at the selection. Okay, then you see volumes, and so you can activate volumes, you can activate transparent, for example, and deactivate volumes, so whatever you want. Now we need the hinges. We will input something, therefore in the input panel, hinges on the both sizes. Selection. I delete it first. I want to input it on all bars with this angle cross section. So I select one of them, and I am lazy man. I don't want to select all of this. I want to filter them. The filter is with the right mouse button on some property. So I want to select all members with the same cross section. Then I click with the right mouse button on the cross section property and go to expand selection, and you see all these 4 bars are selected. There is 1D member, 4 of them. And now if I say hinges on the end of the beams, so then they are automatically inputted on all these selected members. So this is about the filter. There are also another possibilities, but this is the basic one. I think we have almost everything. No, we need to change this one and say this is FEM type is axial force only, and I have to change the direction, so I can activate or deactivate transfer. I need to rotate these beams, so I select the beams. I do it manually, or you can go, no, not everything, because the same cross section is also for another beams. So they should be rotated. Use please this rotation of local coordinate system 90 degree, for example. How do you see the local coordinate system? So I deactivate it, right mouse button, go to the view settings of all entities, then you can change everything. If you ask how can I change something on my screen, how should the structure be displayed, or what should be displayed, then go to this view settings. And then, for example, there are local axes of 1D members. Apply, then you see them. But you don't see the labels. So they are in labels. Labels, 1D member, activate them if you want. But you see there are same color. Red is the X direction, green is the Y direction, and blue is the Z direction. So I don't need the labels, but I need, for example, the cross section. Draw cross section, apply, and then I can close it. So now I can, oh, it's rotated already. So I want to have this long beam should be go below of my frame. It's hanging on my frame. So therefore I need eccentricity. So that's easy. I could write eccentricity, for example, minus 200 millimeters, then it's below. But then this eccentricity goes to the calculation. I don't want to have it. Not each time you want to have this eccentricity in the calculation. Sometimes you need these eccentricities only for the nice drawings. And therefore, there is the structural model. In SCIA Engineer, you have the finite element mesh. This is the lowest level. Then you have the analysis model. For example, this one beam is one member, but for the calculation, we need 2 finite elements. Then we have one member, and we can have also so-called structural model. The properties of the structural model are visible only for the drawings. They don't go into the calculation. The structural model is usually activated. You can go to the project settings, you can check it. Project settings. And then go to the functionality. There is the structural model is activated. And now I can change the properties of the structural model. Is here structural model, there is the alignment to top, and then I can also write an eccentricity of minus 90 millimeter over I'm here, minus 90 millimeter. So, and I see nothing. Why? Because I have displayed the analysis model. You can go to View, Visualization, Generate Structural Model, and you see it. It's not very nice. We have to change a little bit. But we see the eccentricity. And now I would like also to have some this nice cutting. So this column should go through, and this beam should be cut it on the end of the surface of our column. And this will be done with priorities. If you select the members, this is only for 1D members. Then you can change the type, for example, to column. And this number decides how important is the member. Member with higher number cuts the member with the lower number. So we select these two, and they are, for example, 80, and this one will be also 80, and this one, and this one, and all these same cross sections, they should be type with something with 0, general, or you can go to roof bracing. It doesn't matter. The number is important. And now I can again look at the general model. If you want, you can activate that this model will be generated each time, and this is in geometry and graphic settings, and then you can activate immediate refresh of structural model. Then each time you see the actual structural model, you can then activate also these nice drawings of these eye sections and so on. If you want to see back the analytical model, then right mouse button, view settings for all entities, and change the structural model to analysis model, apply, and you see the analysis model which we will use. The another one is for drawings, and it's used if you export the structure to IFC file. Each time you export IFC, this structural model will be exported. I think we have everything drawn, and I have to connect the structure. The structure will be connected automatically during the calculation. Why do I need the connection? So first I save this file. Sorry. I have to go to my folder. 2020 Portal Crane English. Portal Crane. Okay. I move this node. And you see they are not connected. That's not very good. In SCIA Engineer, you draw the members, not the small beams. You don't need to split this member to 2 beams, because if you have some truss member, for example, and you want to change the height, then you had to recalculate each height. So therefore, use these long members. It's also good for the export. You have small amount of your 1D members. It's also good for the check and so on. But they have to be connected, and it's defined in the mesh settings that this connection, connect member nodes, will be automatically done during the calculation. But we have some complicated case here. So I go back to this view settings, and I put off the cross section and local axis. They go through, and this is also going through. They don't have a common node, so they don't know something about each other. So we have to connect them, and I don't want to have the node, a node in the middle of them. For this, we have this, where is it? Crosslink. Crosslink could be fixed, hinged, or with a coupler where you can define each rigidity, if it's free or rigid or something else. But I go to fixed. It's a small tutorial. And now I want to connect this column to this frame beams, not to this long beam. And if we run it in the automatic calculation during the check, then it would be done automatically. I cannot influence it, and I want to have it on this way. So therefore, I select these beams and want to connect them. The connection is in Modify and Connect Members and Nodes. If nothing is selected, then it's run for the full structure. But if some parts are selected, then only these parts will be connected. Don't change the settings, that's okay for the start. Okay, now they are connected. You see there is some relative node, and this node connects B5 and B16. We see it here. This is B5, this is B16. Now they are connected, and not this B15 with B16. So now we have the correct connection. You can activate or deactivate this member data here. Okay, the structure is done, and we can go to the loads. Before I go to the loads, I would like to explain something about the rotation. So back. If you select one beam, then you see here is alpha, and there is rotation of local coordinate system, and you will need it in the future. So this is my member. I draw this member from left to right. This is the node I and J. This is then the x-axis. Horizontal we have y-axis, vertical we have z-axis. This is my member. So it's a little bit. This is the drawing of my member. On this local coordinate system is connected the cross-section. On the local coordinate system, they are connected also the hinges. So I can draw some hinge, some vertical hinge. So, and also loads are connected to the local coordinate system, to this local coordinate system. If you rotate with the alpha, what happened? We have beam. The coordinate system remain on the same position. Also the loads, also the hinges. Only the cross-section will be rotated. This will be then my cross-section. Everything stays on the same place. What is the problem then? Later, during the interpretation of the results, you look at the results and you want to see MY. What is MY? MY to the local coordinate system or MY to the cross-section. You have to decide it. And the same also for the buckling length, for example. So therefore, I prefer the rotation of local coordinate system, at least at the beginning, because then you have x-axis. Then the coordinate system will be rotated. With the coordinate system, you have also the rotation of your member, you have the rotation of your loads, and you have also the rotation of your hinges. So everything which is connected to the coordinate system will automatically rotate. So therefore I prefer, at least at the start, this functionality. Now we can go to the loads. For the loads we need first some load cases. They are here, libraries, loads, load cases. You see also the shortcut, load cases. Self-aid is each time defined in some project. If you create a new project, self-aid is there. You can delete it, but it's usually there. And self-aid is usually some extra load case where you cannot input some additional loads. If you have some permanent loads and dead loads, you have to input it in some extra load case. You cannot do it in the self-aid. Self-aid is very important for you because if you see the somewhere deformation of your structure from self-aid, you know the mistake is in the definition of the structure. Some hinges or something is not connected and not in the loads. Because if you see where deformations from standard load case, where you have inputted your loads, you don't know is the mistake in the loads or in the structure. So therefore self-aid very important for check of the structure. I use the name G1 every time. So, and we will input 4 loads. So here one in the middle, in the 1/2 of this length. Then here, this is not the middle, here is the middle. Then in this node and then in the middle here. So 4 load cases, this one. So therefore I need 4 load cases for cranes. I say K1, crane load. This is not permanent, this is a variable load, and the variable loads need to be grouped in load groups. In the load group, you have the definition of the action. This is here. For example, vehicles below 30 kilonewton meters. This defines your psi factors for the combinations. And you can also say what is the relationship between the load cases? Are there friends? So they can be also in one combination, all in the standard. In standard, in the combination, can happen that only one load case is going 2 or 3 from this one group, or all. But in our case, we want to have so-called OR group, so that only one load case from this group should go to the combination. Therefore, I select exclusive. So that's everything. You can change the name of the group, it's not bad. Load group C, or I write K for cranes. So, and then we need 4 of them, new, and new. So here you can change the load case, which is active at the moment. I deactivate the names. And you can simply input the load. Where is the load? I have defined this input panel to workstation structure. I change it to loads. You can go to all and then you see everything. So if you prefer it, I prefer to see everything on the screen. So I will input nodal load with -20 kilonewton. That is going to the top. This is standard coordinate system for each CAD software, and also SCIA is using it in global coordinate system. If the node have local coordinate system, you can also input the forces also in local coordinate system. You can rotate it. This is not the matter of this training. So click on it, escape, it's done. Now we need the distance of 1 meter from the end. This beam was drawn from left to right, so this is the end of the beam. So we need to input the new load on the beam 1 meter from the end. So I change the load case, and then I input 1 force on 1D member, again -20 kilonewton in Z direction in the global coordinate system. Position is absolute. I want to input it in meters, 1 meter from the end. Okay, and select the member. Why meter and not millimeter? This is defined in the units. You can change the unit system, you can change the units for the lengths, for the input of the lengths, but you can change almost everything, all units, what you want, cross sections, because SCIA Engineer stores all this inputted data in internal units. So if you change the units, you can immediately refresh the view and you see it every time in your user-defined units. So, and the next one should be in the point, again -20 here, but this is a mistake. I want to have this in another load case. This should be in K3 and we are in K2. So I can click on it and change the load case to K3. And if I look at the K3, then I see that my force is there. And now we can go to K4 and input again point on load. This can be relative in the half of the beam, and this is then here. And escape. So we have inputted all loads. I don't need to do it also on the another side because it's a symmetrical structure. I save the time for the training. Everything is done. We can run the calculation and go to, oh no, load case combinations, sorry. Combinations, they are already defined. We have defined VR in Eurocode. We have the standard Eurocode annex. If you select another country, maybe there are some another coefficients. But SCIA Engineer automatically creates also the load case combinations for ultimate limit state, for serviceability limit state. If you have concrete structure, then also the quasi-permanent combination is defined. If you have earthquake loads, then also the earthquake combination is defined. You can create a new one. You can create new combinations, and there are more types. They are linear. In linear combination, you get only some of your load cases with the factors which you define. So in this combination, the software is doing nothing, only multiply the result of the load case with the factor which are defined from you and sum of all load cases which are in the combination. Then there are envelopes. In envelopes, you define the safety factors and SCIA Engineer combines. And in these Eurocode combinations, SCIA defines the safety factors and also combines. You need to do nothing. This is everything automatically. So I will create some special video about the combinations. Okay, we have prepared everything. We can run the calculation. The calculation can be started here from this workstation area, or you can go to calculation mesh and run the calculations. I do it from here. This is the linear calculation. We need to change nothing. This is linear calculation. It's enough that we have one finite element for each beam. Also, the mesh is defined. This is a finite element software, so then we need some finite element mesh. You can see it. Right mouse button, so I can deactivate the loads. Right mouse button, go to the view settings of all entities. You can see the mesh. If you want, you can see the labels of mesh, the 1D elements, for example, apply. And then you see this column is split into two finite elements. And also this beam is split into three finite elements. So everything is there visible. And we can go to the results. For example, I am interested in the global deformations from self-weight. So here are the results. So you can simply click on it. The results are also here, 3D deformations, then support 1D members, everything is here or here. So 3D deformations. If you are in deformations, you have to decide some things. You have to decide on which elements you want to see the results. This is type of selection is all. There is one setting important for this. This is in global UI setting, maximum number of entities for selection. If you have more than 100 entities, which is usually the case, then here the type of selection is changed to current, and then you have to select the beams. So this was for old computers. I change it to 1000, for example. Doesn't matter. So for all. From which is the input of the result, load cases. And then if this is defined, extreme values, but this will be explained later, click on refresh. And then you get the results, the deformations. So see, this is a little bit ugly, but we have for all these diagonals, we have only one straight line. Why? Because we have defined them as FEM type only axial force, so they don't have bending moments. You can do it also for these ones, but that's okay. The angle can take also the bending moment from the self-height. So this is from the self-height. You have to give to your professor or to your customer something on paper, PDF or Word file or something else. So you have to get these results on a paper. So you can do it on more ways. Simply right mouse click somewhere on the screen, and then you have possibilities. Print image. Then you can print this image, change the scale, for example, fit, okay, write the caption, change the printer and print it. So that's very simple. You can change also this this layout and create it new. Okay, I don't do it, I don't need it. Usually, so you can print, you can save to clipboard if you want. This is what I am preferring because I do sometimes presentations, I need it for PowerPoint. But you will usually collect these results in engineering report. The engineering report had one advantage. All things which are in engineering report can be refreshed. So if you put some picture there and you change the structure, you can click on F5, F6 and refresh the engineering report so that you have the recent status of your results or input data. So there are three ways how to send the picture to report. Screenshot is a stupid picture, cannot be refreshed. There are live images with scale. We don't need scale in this 3D. Live image to report. This is the standard way how you will do it. I will explain only the basics of them. So, and sorry, I close it. I have to start engineering report because I don't have an engineering report in my project. Therefore, I cannot put it there. So I have to start some report. I go here and start one engineering report. Then you get a new window. Engineering report is a new window, a new application in Windows, but they communicate in background. The advantage is you can create more reports. All can be opened and all communicate with the engineer. So in engineering report there are some templates, but I use only this empty report. I input there header, footer, some with double click, some content, page break, 3 chapters, 1, 2, 3. In the first chapter I have input data. I do only the basics because I have a special video for engineering report. Results and steel checks. Okay, I leave it open. I go in SCIA Engineer, right mouse button again, live image to report, and then you can change the properties. So 1 picture per page, standard, it's okay. You have 2 possibilities how to create pictures. Pixel graphic, like JPEGs. And this is used for these shaded pictures. And then you have the wired model. The wired model creates smooth lines, a vector graphic. So if you export this engineering report to PDF, not print, export to PDF, you get smooth lines in your PDF. Also the numbers can be read a little bit better. So I stay on standard, activate only this automatic scale and simply insert it in my engineering report. Later we go to engineering report and look at it. Or we can do it now. In engineering report you see then the picture, you can move it somewhere. I want to have this picture in the chapter of input data. I can move it on this chapter, but go a little bit to the right side. You see the cursor is rotating to the horizontal direction, and then this will be indented into the chapter. You can do it without an indent also, but now we have 2.1, so it's in the chapter of input data, and you see it also in the table of content. I do it a little bit bigger. 2 is input data and 2.1 is the picture there. Now we can look at another results only very briefly. For example, bending moments for this frame. So I select these members, not this one. Deselect this with shift. So if you click with shift on the same member, it will be deselected. Okay, so if I don't want to see these results, simply take these results, move it a little bit to the right into this basket, and the results are gone. So we can go to internal forces. I will see the internal forces only on these 3 beams. Therefore, I go to the selection current, and I want to see it from the load case combination for the ultimate limit state calculation. What do I want to see? I want to see bending moments, MA. Refresh. And you see only one result for maximum, one result for minimum. This is because extreme values are defined to global. So we can go to local and again refresh. If you are tired with this refreshing, you can activate, here is it, automatic, you can activate it and then it will be refreshed automatically, only applicable for smaller structures. So if you have big structure, then I do it manually. So I can activate it here. So what we don't need are the units, so you can deactivate them and you see immediately what is changed. If you need this picture, again, right mouse button. But if something is selected, then the right mouse button and the printing into the engineering report is a little bit hidden in this view, and then go to live image to report. I want to change this rendering to wide. Then I get smooth lines, which I need. I need this picture as on 2 per page, okay, automatic scale. I don't want to change this setting each time. I save this setting, for example, into the button 2. And then later, if I click on this button, then I get all these settings back. So then we have in engineering report a next picture. And here is it. So we can change the size if we want, or we can simply move it into the results. And I think that's everything. Tables. If you need some tables, all these results you get also in preview. And then you have a preview table where you can check it. You can print it if you want. You can click on right mouse button and say table to engineering report. Then you get this table from the preview into the engineering report. And there is also a result table. This is a little bit different than the preview, because in the result table you can filter, or you can simply copy it, Ctrl+C, and paste it, for example, in Excel, and then you can do your calculation, for example, for supports or something else. If you have your own calculations in Excel, a lot of companies have it, then you can copy paste it from SCIA Engineer to the Excel. Now we need the steel checks. Steel checks are here in this workstation for steel checks. I will delete the results or remove the results from the screen. And for steel checks, you need the buckling length. The buckling length is calculated automatically or half automatically in SCIA Engineer. You have to check some settings for the beams. The buckling length can be inputted manually. You can run the standard calculation of buckling length, which is included in SCIA Engineer, but you can also run the stability calculation and read the buckling length from the multiplication factor of your stability combination and from the axial force. Then it's automatically transferred through this Euler formula to the buckling length factor. We will use the standard calculation. For the standard calculation, we have to know if the structure is sway or non-sway type, because there are 2 formulas for the calculation of buckling length, which are included in SCIA Engineer. One formula is for sway, one for non-sway structures. This formula uses the stiffness of the nodes, and the stiffness of the nodes is calculated by hidden horizontal loads. these horizontal loads move the structure, they cause deformations and also bending moment, and from the rotation of the node and bending moment, we can calculate the stiffness of the node. We know also the bending stiffness of the member. If you compare it, then from these two formulas, you get the buckling length factor. The buckling length factor multiplied with the system length gives you the buckling length. So first we need these system lengths and the decision if the structure is sway or non-sway. This decision can be done in the steel settings. There is the sway. You see, around the strong axis, it's sway. This is standard for frames. You have the frame and its sway type. And for the weak direction, so around the Z-axis, around the weak axis, you have some wind bracings or walls and something else. So I leave it. It's not bad. But I have to change it for these two columns because this structure can be lose the stability in this direction on this way, and this is a sway type. But for the orthogonal direction, this can go also in this direction. So we have here this wind bracing. This creates some rectangle, but this is free. So therefore, I have to define it in this direction as free and also in this direction as a free. And this is different from the standard settings. Therefore, I have to click on my beam or column, go to System Lengths and Buckling Settings, click on this setting button, and now I am in the library of the buckling settings. You see there is this green arrow. This is the sway type around the strong axis, and this is sway. Around the weak axis, we have this cross. That means this is non-sway. So this is what we have to change. Sway around weak axis is sway. So we have this one. We have also, you see, there are two spans, and around strong axis we have only one span. SCIA Engineer recognized there a node, but this node is free. This is not supported in this direction. It's supported only in this direction here, and we have here a support. So we have support of this beam on both ends, but not in the middle. Therefore, for the calculation of buckling length, this buckling length factor around strong axis will be multiplied with this long length of the full member. And around the weak axis, we have here a beam, and therefore the KZ, this is the buckling length factor for the buckling around the weak axis, will be multiplied with this LZ. And this gives you small LZ, which is the buckling length. So that's correct defined. We will save it. This definition has a name BG1 and can be used for another steel members with two spans. And we have another members with two spans. These are these remaining three columns. I can simply select this BG1. And that's everything what we need. The buckling lengths are defined. We can check them. There is this steel slenderness. Oh, this is this activation, automatic activation, you see. Sometimes not very good. So I select only this member. Selection to current. What do I want? The system length around the strong axis. This is the full length. Then the buckling length factor around strong axis 2.3, and 2.3 times 2.7 gives you the buckling length around strong axis, and the same around weak axis. So the system length 1.3 and 1.4, because it's split it, times buckling length factor 2.9, you get the buckling length for this part and this part. So these have to be checked before you go in the checks. If you are going to the checks, then it's very easy. You simply go selection all. We select the load case combination, say the extreme values. I say the extreme value for one member, and output level is only brief output. That means one line with the results for each member, because we have extreme values for members. Everything is done in background automatically. Classification of the cross-section. If it's cross-section 1, 2, 4, it's classified automatically. According the slenderness and the force, the internal forces, SCIA Engineer decide if some checks are necessary or not. This is done automatically. We will create some pictures. I show you also the detailed results. So this is one overview picture. Right mouse button, go with this picture to the engineering report. Simply select these two and send it there. You get it also in the preview table. Then you see one line for each 1D member. And then we get these results. Move a little bit, please. Make it a bit bigger. So, and then you see the utilization for section check, utilization for stability check. Some warnings, for example, slenderness is too high and so on. If you want to see the detailed output, I do it, for example, for this member. You have also the standard summary. This is a standard output. We can go to detailed. I change the selection to current. If you get detailed output, you can have tables in the output, formulas, or both of them. I do it with both. Also the decision table. Refresh, go to preview. This is the utilization 0.63, and then we get the detailed check result for our 1D member. So you see everything is done automatically, but you have influence. Here in this button you have so-called 1D member data. You can decide that this is not the class 3, you can say this is class 2 or class 4. You have the decision. You can say you don't want to have plastic check, you don't want to have stability check, for example. There are a lot of results what you can see, but you see this is automatically decided. These are the internal forces. Then we have the classification. I have activated this semicom plus. Semicom plus is for class 2 cross sections. They close the gap between plastic and some jump or spring between the plastic and elastic cross sections. And then you see all these checks as a table, because I have decided table and formulas, and also the formulas with nice all units, all results, and reference to the used to the Eurocode or some national annex. So you see everything. Also the stability check. You see, for example, the calculation of M critical for the lateral torsion buckling, N critical, and so on. Everything is there. So, and you can print it into the engineering report. There is also auto design. So if you get some red color, it's overutilized, you can run the auto design and decide the software to select the best cross section for you. That's all for the checks, and we can look how to export the engineering report. So I don't create a new chapter. We are in engineering report. I simply move this picture into it. I would like to have also these steel checks in my engineering report, but I don't want to send them from the SCIA Engineer to engineering report. You can collect almost, I think, all tables directly also in engineering report. Pictures have to be sent from the model to engineering report. There are some generators also. If you are interested in engineering report, there is one special video for it. And then we need the steel check, ultimate limit state check, and This will be included into the chapter. I say for all beams from the combination, extreme value for each member. I want to see the brief output, and then I copy it. Ctrl C, Ctrl V, copy paste. And change the extreme value, for example, for cross-section. Each cross-section gets one full calculation. And then you can decide here, this is not brief output, this should be the detailed output with tables and formulas and with this decision table. And that's all. You can print some page break before of this start and also after each calculation directly in it. Okay. So I can refresh it. And now I could export or print this engineering report. I make one small change. I like this gag. You can define that some of these pictures are 3D, and then they will be exported to the PDF file as a 3D pictures. And now you can go to this button, and there is a printing, and there is also export, and you can export it as a PDF file. You can go to this portal crane, and I say 1, 2, 3 PDF, and then we get the PDF file. Now it's generated. I can have a look on it. For example, click on this. This is this 3D picture. Say trust this document, and then you can simply rotate it right a little bit. It's a PDF, so, and you can move it. There are some ways how you can define, but this is PDF or Acrobat already. This is not SCIA Engineer. So you have then all these results in your PDF. You can, of course, export the engineering report to RTS, read text format. This can be used in Word. You can then read this, open this file later in Word and make some changes, for example. So go back to SCIA Engineer. I think that's everything what I wanted to explain you. It was very basic tutorial. I didn't explain all these details for all these properties, but this is not necessary. So I hope you enjoyed the tutorial. Thank you very much for your time, and bye.